So data types. And these are going to be simple data types. So our first data type is going to be integral data types. So, whoopsies. So, integral data types are going to be data types that deal with integers. And what are integers? Those are going to be numbers without a decimal. We have a few different types of integral data types. The first one is going to be int. Int is going to be things like -2, -1, 0, 1, 2, and so on and so forth. They're whole numbers. They're not numbers like 2.3. That is not an int. Or 2.7 or 153.8. Those are not integers. They are only whole numbers. You have a couple variations of them that we'll go over the differences between them here in a minute after we go over a couple more integral types. They're going to be short, which is going to be smaller than a regular int, which is going to be smaller than a long, which, I mean, technically these two are the same. You'll see in a minute, but that's okay. Which is going to be smaller than a long. And then you also have unsigned versions. And these are going to be unsigned short, unsigned long, or int, unsigned long, and unsigned, let's see if we can fit it, longs. And these, I know, are just a bunch of things to you right now, but let's put a little divider line in there, because eventually I'll share all these notes with you. Hopefully today I'll remember to do that. These are just going to be, this one is greater than this one, or less than this one, which is less than this one, which is less than this one. And then same with here. This one is less than this one, less than this one, less than this one. And we will see here in a minute what that less than means. We also have Booleans. And these are going to be just the two values 0 and 1. 0 is going to stand for true. And 1 for false? No, that's wrong. That's wrong, sorry. I don't know why I have it written that way. Sorry, I write these notes very quickly. And those are going to be things that we're going to be able to test later on. And then we also have things like Char. And Char are going to be like the keys on your keyboard, like A, B, everything there. It's going to be things like exclamation point, question mark, period, so on and so forth. You can have things like 1, 2, and so on and so forth. And really, why? Like, you would ask yourself, Alex, you said integral types are like numbers. Why are you showing me a bunch of characters? Well, in a computer, these characters are actually a bunch of numbers. And those numbers are found on the ASCII table because computers read ASCII. I don't know if I'm saying that right. But if you see here, you have things like, let's find some things. Oh, let's pop over the desktop. Okay. So if you see here, we have things like, here's your characters like A, B, C, D, E, the whole capital alphabet. There's a number that's associated with them that goes all the way from 0 to 127. Okay. And then as you can see, the capitals are different from the lower cases. You've got all the different little characters you see on your keyboard, like the open curly brace, the closing curly brace, the pipe, I believe they call that. I don't know. The tilde, the closing brace, the opening brace, the backslash. Anything that's on the keyboard basically is going to be an ASCII character. ASCII. There we go. ASCII. And I see a question from somebody else. I probably should have paused in between things. I'll answer that question in just a minute. I'll start pausing in between. Don't think I'm ignoring your question. I don't think I'd remember that. Yeah, you don't need to remember these per se ever. I'm never going to ask you guys to like spit these numbers out on the test. But like, if you need, I don't think we have any problem sets where we're going to be manipulating this kind of stuff. But if you need to, you definitely can. In 218, which is the next class, you'll start manipulating this kind of stuff. And you'll see why this is really important. But you guys just need to know for now that like these tie back to a decimal number. Or yeah, not a decimal number, but an integer number. Okay, back to the iPad. All right, cool. So we've gone over the ASCII table. So we've got ints, bools, and characters. And now we have a bunch of things to go over that are, I probably shouldn't have switched from desktop, that are, well, Alex, what was all that later, greater than and less than before? Oh, it doesn't show on this one. Let me open up the master. 1 second, because these numbers are kind of important. I'm not going to ask them on a test because they're kind of ridiculous numbers to memorize, but yeah. Week 2 master. Just so slow. I wish I could just hold my iPad up to you guys, but that wouldn't be very... that wouldn't work. That would be so terrible for everybody involved. Okay, so let's go down. Here we go. So here are all the integer types we were talking about a minute ago. And you were like, Alex, what is all this less than equals stuff? This is what we're talking about with less than equals. So a short, if Google Docs would click on it, a short is going to be 2 bytes. And wow, this is just terrible. I can't do anything. Okay. Technology, man. Apparently you can't stream and use a computer at the same time. But we'll fix that later. Can't fix that right now. All right. Come on, baby. All right. This is very important that I click on this because I can't just point to it for them. I can't point at a monitor. Come on, Google Docs. Okay, so we have a short. A short is 2 bytes, which we went over in the overview of a computer, which 2 bytes as a signed short, which means it can hold negative and positive values, is going to be negative 32,768 to 32,767, which is a terrible number to remember. That's why you'll never need to know that on a test. An integer is 4 bytes. It can hold this god-awful number that I forgot to put commas in to this number, which is what? 2,447,483,648 to that, well, negative that number to positive that number minus 1. You won't need to know that. Then a long is even bigger, where you can hold, I don't want to say that number. That's a really large number, but that's the range you can go to. So when you do an unsigned version of these, obviously it's going to pretty much double plus 1, the amount that you can hold in the positive range. So in unsigned short still holds 2 bytes, but instead of going from negative, it goes from 0 to 65,000. And then an unsigned int goes from 0 to 4 billion. And then an unsigned long, which is the same thing as an int because they're both 4 bytes, goes to 4.2 billion as well. And then this unsigned long goes to 18.446, whatever that number is. And then you've got things like bool, which were 0 and false, which can only hold the values 0 and false, or 0 and 1, which is 1 byte. A 0 you can hold in 1 byte, and 1 you can hold in 1 byte. And then chars are also the values negative 128 to 127, which we just went over with the ASCII table. And those are held in 1 byte of memory as well. And that's everything about integral data type.